Hybrid scores drift because BM25 and embeddings do not mean the same thing. Isotonic regression gives you a practical calibration layer before fusion. This is the pattern you'll be able to implement by the end, which calibrates hybrid relevance scores for a steadier ranking. I'm Professor Pi, teaching search and IR with simple Python. Search engineers often fuse signals from a lexical retriever like BM25 and a dense embedding retriever. The problem is simple to state. The numbers coming from each stage live on different scales. One model outputs tens, another outputs decimals, and a reranker may return scores that dominate the mix. The result is unstable top results and user complaints about inconsistency. Isotonic regression is a monotonic calibrator. It learns a non-decreasing mapping from a raw score to a probability or calibrated score. In plain terms, higher hybrid scores should never map to lower calibrated probabilities. This keeps order consistent while adjusting for scale mismatches. We will build a tiny pipeline to make the idea concrete. First, we create toy BM25, dense, and reranker scores that conflict. Then, we rescale, fit an isotonic calibrator with simple labels, and use it to stabilize a fresh query before picking top contexts. Quick note, this code is designed to teach the core idea clearly. Library versions and local setups can vary, so check the official docs if your setup behaves differently. Now, let us create the toy signals and show how naive fusion misleads the top result. This snippet builds toy lexical, dense, and reranker scores to show how naive fusion mislabels the top document. The docs array names 8 candidate passages that we reuse later, so the pipeline stays consistent as we change pieces. BM25, dense, and rerank are intentionally on different numeric ranges to mirror real-world mismatch. Lexical scores in the tens, dense in fractions, reranker dominating. The naive vector just sums those arrays, an unweighted hybrid aggregator with no calibration. The printed naive top doc shows D0 squeaking ahead with 9.96, which is exactly the kind of misleading champion you see when you fuse raw scores without aligning scales. We need comparable ranges before a calibrator can learn from mixed signals. So next, we rescale by query and attach labels. This example normalizes each signal and attaches relevance labels so the calibrator can learn from comparable hybrid scores. A helper min-max rescales any vector to the 0-1 range using per query minima and maxima, which gives each retrieval channel equal footing. Labels are simple binary judgments for the 8 docs. Think human clicks or manual relevance that tell the calibrator what really mattered. After min-max, BM25, dense, and rerank become scaled arrays. Their average is base score, a crude but uniform hybrid estimate. The printed baseline mean and positives show the aggregated distribution and how many relevant samples will drive the mapping. Now we fit isotonic regression to translate the base hybrid signal into calibrated probabilities. This code fits scikit-learn's isotonic regression to translate the baseline scores into calibrated relevance probabilities. Isotonic regression enforces a non-decreasing mapping, so higher base scores map to equal or higher probabilities. We set out-of-bounds clip so future inputs stay in the learned range instead of allowing risky extrapolation. The fit call consumes base score and labels. Isotonic handles sorting internally, and transform converts each baseline score into a calibrated probability stored in calibrated. The printed calibrated mean and may give a quick sanity check, about 0.50 average probability and 0.20 mean absolute error, showing the learned curve tracks the judgments reasonably well. With a fitted calibrator, we can apply it to new queries and combine it sensibly with reranker judgments to respect both sources. This snippet applies the fitted calibrator to a fresh query and blends it with reranker scores to stabilize ranking. BM25 new, dense new, and rerank new are the raw signals for the same document order under a different query. Min-max rescales them to match the training range, and their average becomes base score new, so the calibrator sees comparable inputs. Calibrated new holds the probabilistic mapping for the new query, and stable mix blends 60% of that calibrated curve with 40% of rerank new scaled, to respect reranker judgments without letting them totally dominate. The printed summary highlights that D4 now leads at about 0.88 probability, replacing the naive top D6 for this query. A concrete example of calibration plus a simple blend giving a more stable champion. Finally, we pick the top contexts for downstream use: deterministic and confidence-aware. This example finalizes the calibrated blend by selecting the top contexts that downstream RAG retrieval would consume. NumPy argsort on stable mix produces order, a descending index list ranking every document according to the calibrated combination. Slicing the first 3 entries retrieves top docs and their probabilities in top scores, which makes the selection deterministic for downstream pipelines. Joining the document IDs in the print call gives a compact view of the chosen contexts, and mean prob reports their average confidence. The printed line shows D4, D0, D6 with a 0.83 mean probability, which motivates using those passages for the final answer stage. Isotonic regression maps hybrid scores into monotonic probabilities, so rankings stop flipping just because channels use different scales. Use it when your retrievers, BM25, dense, reranker, output incommensurate ranges, and you have some relevance labels to train on. One caveat: the calibrator needs representative labels across the score range. Without coverage at the extremes, the mapping will be weak there. Scale this pattern by fitting the calibrator on many queries. Serve the transform inside your retrieval pipeline, and watch latency and calibration drift as you go. If short, practical IR helps, subscribe and watch the IR videos.